Alright guys, so this is the lab. You're going to see this sheet again. If you click on this, you go right to the gizmo. So those of you who were wondering what's an easier way, just click on that. You can click on the link that's linked to it. Write anything that is orange boxed, you are going to fill in. So name. Please write your name. And first off, you got some vocab given to you. You've seen some of this before. And please fill these in. Which rock do you think has been exposed to Earth's surface the longest? And why do you think so? So this one, which one, A or B, and why do you think so? So the warm-up. And once you click on weathering the gizmo, when rocks are exposed, they are gradually broken down into the soil by actions of rain, ice, wind, living organisms. This process is called weathering. In the weathering gizmos, you will explore how weathering takes place. This one's going to be a little bit longer than porosity. So to begin, select the simulation tab and notice selected rock type is granite, a hard, dense rock. So you go to this stimulation, you're on granite. Click play and wait till about 5,000 simulated years. Then click pause. What do you notice? So what it wants you to do is just push this and wait until 5,000. Then click fast play till you hit 50,000. So I'm going to hit play till 5,000, then I'm going to do fast play to 50,000. What do you notice? Based on the observation, is weathering a fast or slow process? All right, so get the gizmo ready. Select animation tab. Check the frost wedge selected. So I want to make sure I do it properly. Select animation tab right here. And we're going to go to frost wedge. That's what it's looking for. Oh, sorry. Read the text about frost wedge, then click play. And then you're going to answer these two questions. Observe. Read and look at the animations for the other major types of weathering: abrasion, pressure release, dissolving, clay formation, and rusting. And so you're going to go abrasion, pressure release, dissolving, clay formation, and rusting right there. And then after you're done answering these questions, you're going to go in and fill in right here. So the term oxidation, carbonation, hydrolysis, and exfoliation are terms scientists use for different types of weathering. Fill in these four things with one of those words. You've got your word bank, so label one for each and fill it in. Then you are going to select other, and it's going to give you salt weathering, heat expansion, root weathering, and lichen growth. You are going to place A, B, C, and D in the box in the correct order, matching with the term. All right, categorize. List all the types of mechanical weathering you have learned about in the left column right here. Remember, mechanical is physical. And on the right, all the chemical. All right. Then you're going to interpret. Based on the descriptions and images that you've already learned about, guess which type of weathering is shown in the images below and explain each answer. And I'm going to highlight that because some of you keep forgetting to explain. So in the honeycomb of Spain right here, A. Stalactites in South Dakota right there. Split rocks in Scotland, place I really want to go. You're going to tell me what type of weathering and how you know. Here's an example. I really like this one. This could be something called frost action. Why? Because the rock is split in half by the cold and the warmth. And yes, Scotland has lots of water. So, and it does get cold and it does get warm. All right, so we're going to get the gizmo ready for activity B. On the simulation tab, you're going to click reset. Set the average temperature to 25 Celsius and precipitation to 250. So simulation, we're going to be on reset. 25 and 250, right like that. So the weathering gizmo lets you explore weathering of 4 common rocks: granite, sandstone, limestone, and shale. So the first type you're going to be dealing with is granite, and my computer's being awfully funny. All right. Below rock type, select granite. Click fast play until you hit about 100,000 years. Click the tool palette and select screenshot. Right click the image, copy, then paste the image below and label this image granite. It's already labeled right there, so all you got to do is copy paste. So this is just an example. This is not what you're doing. Say that's at 100,000. I'm going to go down to tools. I'm going to click screenshot. Let it process. Okay, it says right click image to copy or download. Right click, copy image. I'm going to go back over here and I'm going to paste. It's as simple as that. Copy paste. All right. Describe what you see. Look at weathered rock above the outcrop. How much rock was weathered? Okay. Rock type, weathered rock. So right here where it says weathered rock, it'll tell you how much. So how much was weathered? It says it right here. If I could highlight it, I would. Like right here, this area. Okay, you're going to reset and do the same procedure for sandstone, limestone, and shale. To get to those are simply, you're going to go rock type, sandstone, shale, limestone. Okay? Compare which rock tends to weather into round shapes. Which one does caves and lumpy hills? Which one does the quickest and which one's the slowest? All right, so we're going to click reset again. Go to granite and click fast play. So granite, you're going to click fast play and run the simulation until you can see large cracks forming in the rock. This may take a while. Be patient. Take a snapshot of the resulting outcrop and add it to your document. Label this as granite cracks. You know what? I'm going to make it a little easier. I'm going to put that right here. So you're going to put your picture right in here. What type of weathering forms these cracks? Hint, you may need to review the different types of weathering on the animation tab. Some types of weathering only affect certain types of rock. The types of weathering that apply to each kind of rock are listed above the outcrop. If a type of weathering does not affect the selected rock, it is faded. So what it just means is right here, types of weathering. For granite, dissolving doesn't go with it. If I choose limestone, clay formation doesn't go with it. Shale, no dissolving. Sandstone, no dissolving. Okay? You're going to list the types that are right there, and I kind of just showed you. You're going to look right here, right there. Another thing you can see right here, if you want to get a snapshot, you can do a snapshot right there. But again, with the tools, once it pulls down, you can take a screenshot there. So both of these will do screenshots. So for instance, I can do that. It'll process. It's the same thing. Okay. Note, sandstones are only affected by clay formation when they contain minerals other than quartz sandstone that are pure quartz and do not form clay. Activity C. On the simulation tab, select sandstone. Check that frost wedging, clay formation, and others are selected. So it's sandstone. It wants frost wedging, clay, and other. Yep, it should be all set. The most important thing that determines how quickly a particular rock type weathers is the climate, or typical weather conditions. Rocks in cool, dry climates weather much differently than rocks in hot and rainy. So predict, highlight, that just means go like this and click on this and choose a color. Highlight the condition that you think will lead to the fastest weathering given the weathering type. Then you're going to run the original settings, use Gizmo test to affect precipitation on the rate. So when I went back to that and I said redo, I think this was down to 15, this was down to 150. So original settings, yeah, click it on right there. Go to 20,000 years with low and high precipitation. Be sure to keep all the other variables the same. Describe your results. So what it means by this, if I want low precipitation, what I'm going to do is I'm just going to like crank it down to like maybe 20 or 10. If I want high, I'm going to crank it right up there to 290. Describe your results both here. There's the low precipitation, there's the high. How does the amount of precipitation affect the amount of weathering? Click reset, return to original settings. Now test the temperature on the weathering. What it means is you're going to be messing with, you're going to go low, you're going to go high. How does it affect? Explain why do you think the rate of weathering tends to increase at hotter temps and higher amounts of rainfall? Experiment. Click return to original settings and select limestone. Turn off frost wedging and other so that only dissolving goes on. So you're going to go there, you're going to click those off, and you're going to be stuck with dissolving. Use Gizmo, test the effects of precipitation and temperature on the rate, just the same as you did before. Low precipitation, high precipitation. Making sure to click reset after each. And then do low temp, high temp. Summarize your findings. What do you see? Which one does better? Dissolving occurs quickly at low temps because of cold water. Experiment. You're going to run or return to original settings. Select shale. Test the effects of temperature on frost wedging and clay formation. So when I go to shale, frost wedging and clay, unclick other. Effect of temperature on frost wedging, effect of temperature on clay formation. Last but not least, you are going to click on the chart below and to summarize the different combinations of temperature and precipitation. You're going to drag the name of each of the weathering types listed into the box where it would happen most quickly. So you're going to click on that and then you're going to pull and drag. You can drag these where you need to be, okay? And then you are done. I know this is a long lab, so you have a lot of time to work on it. Let me know if you need any help. Email, text, remind. Have a great day.